Hi, can you hear me? Hello?
Yes, we can hear you, Andrea. No worries.
Perfect. Perfect. Thanks a lot, Gael, and thanks everyone for being here. So I am Andrea Micheli. I am a researcher in Fondazione Bruno Kessler, that is a research center in northern Italy, and I am the technical coordinator of this European project funded under the AICE 2020 program that is called AIPlan4EU. And this project is essentially about bringing planning technology to the AI on demand platform that also Martin was talking about, and he was also part of the AI4EU project that initially developed this platform. So I'm not alone in this project, of course. We have several partners, and in particular in this project we are trying to bring this technology that I will talk about in a moment to real companies, to really make the point that planning technology can be actually used in practice. And so we have 9 companies that are providing use cases within the project, and 7 research centers that instead are providing the technology and are leading experts in artificial intelligence planning. In addition, as you will see in the end of the presentation, we have a funding schema, so a cascade funding schema for which we can actually fund sub-projects related to this technology. So we are looking for additional use cases, additional planners or planning engines that can be contributed to our platform, and what we call technology-specific bridges. So pieces of code, possibly open source is better, that actually implement a demonstrator showing how planning can be used in one specific application. So in a few words, what is planning? So essentially it's a reasoning technique. So it's one of those symbolic AI technologies, all days AI. Essentially, what you do in a planner is to reason on a system specification, and here system can mean different things. You can use planning, for example, in a factory to organize the activities of the machines or of the workers, or a system can be the capabilities of a robot, and so the planner is used to decide what to do with the actual robot. The job of the planner is to try to understand how to reach a certain goal, a certain objective that you fix, given the capabilities of the system at hand, starting from a certain initial configuration that you also specify. So some practical examples can be coordinate the activities of different robots. So, for example, fleet robot coordination in order to achieve a desired level goal that might or might not require coordination. And this is intended to provide flexible, more robust, and more cost-effective automation. So, task one of a planner, so the number one value that we can provide is to automate some of the decisions, for example, robotic decisions, and to simplify possibly the programming of these machines. Second example could be flexible manufacturing. So I know what my factory can do. I know what are the capabilities and the constraints of my workforce. And so the objective there is to understand what to do at each moment in time in order to maximize the production and minimize the costs. Another example could be the optimization of resources, for example, in an agricultural domain, for example. So you want to organize the different agricultural practices in order, for example, to minimize the environmental impact. I will talk about this one in a moment. And the project is started in January, so we are, let's say, working actively on all these tasks. What we really want to do, so the overarching objective here is to bring these reasoning techniques, these planning resources and capabilities to the AI4Europe platform that Martin was also talking about, and to reinforce this platform by making planning a first-class citizen in the platform itself. Well, Martin already talked about what is AI4EU. Just in a few words, essentially what we care about here is also resonates very well with what Martin said before. So we want to bring together AI stakeholders and AI resources. In our case, around the planning technology, but of course the platform itself is more general. It encompasses all forms of AI. In order to accelerate innovation, what we want to use the platform for is to show that planning can be actually used on practical application, show how we used planning in order to demonstrate a certain requirement or to solve a certain use case, in order for other people to actually have a look and understand whether this can actually be applied in their business or in their in their work. And so what we are going to contribute here more than everything is a technology, so having a single point access and a standardized way of posing AI planning problems, together with use cases, examples, and training materials that are the byproduct of the activities that we are going to do in the project, that we think is more valuable for the members of the portal of the AI4Europe community. I will go quickly on the innovation goals. So essentially, this is an innovation activity within the AICE 2020 framework. So what we really want to do is to make planning more practical. So not to do research on planning, but more bring the existing technology in a way that is more accessible to practitioners and innovators. And in particular, the objective number 2, I think, is very relevant and important, in the sense that one thing is to have a planning engine that is able to solve your problem. Another thing is to integrate this planning engine into an ICT ecosystem, because most of the times it's not like you have the problem, you pose it to a planner, you have the solution and you're happy. Actually, in order to construct the problem, you need to gather some data from different systems, possibly also distributed geographically or from an architectural point of view. And with the data that you gather, you can create a planning query, one or more planning query, maybe one is not enough. And then the planning engine does its work. So it tries to solve the planning problem the best it can. And then you need to translate back the solution into your ICT ecosystem. So to give you a concrete example, if you are trying to automate the intralogistics for a certain warehouse, you first of all need to interface yourself with the warehouse management system. Probably you already have some kind of ICT infrastructure, some kind of program that abstracts away and knows how many shelves you have, how many workers, how many forklifts, and so on and so forth. You need to gather all this data in order to pose a planning problem, then solve the planning problem, of course, is the job of the engine. And then the planning solution needs to be translated back, for example, into a graphical user interface for the workers in order to know what to do at a certain moment in time, or even to automatically interface some of the machine. Maybe you have automated guided vehicles that need to be instructed. So this is a very ambitious objective, but I think is crucial for making the step from an academic technology to an actually useful industrial relevant technology. Then we are trying to diversify as much as possible the application sectors. Traditionally, planning has been associated with robotics, but by no means this is the only way in which planning is relevant. And so we are trying also with our cascade funding to broaden as much as possible the scope of our project in order to show that the technology that we have is actually relevant for different companies. Then there is the point of integrating with the AI4Europe platform, and I can link myself with what Martin was saying. So we are trying to interface ourselves with the AI4Europe experiments also, so that we are creating sort of a standard way of posing planning problem. I totally agree with what Martin was saying, that it is super important to have standard ways of posing AI problems or to create AI assets that have a standard interface. And what the project is trying to do here is really to create this interface for the class of problem that enters the realm of planning. And then again, we are trying also to make this accessible as much as possible. So create training material for reskilling in order to make even normal citizens or technicians to better understand what planning is and what it can do for them. Yes, and this is super ambitious. So try to also, if you are able to make planning relevant for actual application for industry, we will try to also drive the academic research towards application and less focus on, let's say, theoretical problems or problems that have no immediate industrial relevance. the kind of vision that we have, now I'm jumping a little bit more to the technological, so what we are developing in our project. What we have on the left side of the slides, I don't know if you see the mouse, but on the left side you have the different use cases that we have in the project. We'll briefly go through them. So we have a company that constructs robots for logistics. We have a company that is a consortium of companies working in the field of digital agriculture and machines for agriculture. We have a use case for flexible manufacturing, fleet planning in the sense of there is this company making automated guided vehicles, and they are trying to coordinate them in order, for example, to reduce the number of recharging stations that you need in order to make the fleet working. Human robot interaction, so simplifying the communication between the human and the robot by means of planning. We have underwater drones for surveillance. Lab planning means plan the different experiments that you need to do in your lab in order to test a certain consumer product, for example. And again, we do have cascade funding, so we are trying to extend this stack of use cases as much as we can. Now, from the use cases, our vision is that there's going to be some technologies. For example, in logistics automation, there's going to be certain warehouse management systems that are standard or that are industrially relevant. If you're doing robotics, maybe you are familiar with the robotic operating system, so with ROS. And so there are these kind of technologies for which we want to build bridges. So for which we want to build pieces of code, okay, projects that can actually interface and automatically translate the domain-specific problem to the planning problem that is domain agnostic, so that works for any kind of domain. And in order to do that, we want to construct this unified planning framework, this big blue thing that you see in the center of the slides. This is going to be a library. In particular, we are developing a Python library with additional interfaces. For example, one is in gRPC, so in protobuf plus gRPC, in order to be interfaced with as a standard Docker container with Martin's AI4EU experiments platform. The idea of this unified planning framework is to have a standard way of modeling a planning problem, plus some goodies like capabilities of reading and writing different formats for planning that are existing, the capabilities of simplifying problems, the capability of inspecting problems and plan, and so on. So a lot of user-friendly functions and APIs that allows you to manipulate and to create planning problems. And then this unified planning framework is linked with one or more planning engines, right? So in the consortium, we have seven research centers that are bringing their own engine. In addition, we will try to find more by means of cascade funding again. And the more engines you add, the unified planning framework is going to try to match the problem that it receives in input with the most suitable planning engine that is installed in your system. Again, also here there is the point of IPR, so we are supporting both open source and closed source planning engines, so that if you have the rights, you can install a certain planning engine that maybe is not open source, and the framework automatically detects it and starts to use it in an automated fashion again. And then the flow can be reversed. So the solution from the planning engines is abstracted away by the unified planning framework, and then is provided by means of this technology-specific bridge to the specific use case. So this is basically the grand vision of what we want to construct. This is another view of the same thing. The only additional point here is that out of this experience of what we are going to build within the project, the use cases and the training material will all be available through the AI4EU platform, and the entire planning, unified planning framework, that is the green box that you see in this picture, will be also part of AI4EU because it will be available in the in the experiments platform again. So I would like to give you a couple of examples of actual use cases that we have. Let me see how I'm faring with time. Okay, I will be quick. So here the key point is that planning is a decision-making technology. So what you want to use planning for is to automate or to optimize a certain decision in your domain, in the domain of choice. And there are essentially three key questions that we need to answer in order to understand what and if planning can be useful for your application. So first of all, what are these decisions exactly? So should I decide only the timing of the activities, or also which activities to be performed by a certain worker? What needs to be automated and what instead is a manual input, and whether or not we need to optimize some quality measurement, some objective function. So this is probably the key question to really understand if planning is useful for you or not. Second point is what data is available for taking such decisions. So for example, again, in the logistics domain, there are possibly constant characteristics. So the shelves in a warehouse are probably fixed and are not likely to change from one day to another. Instead, the pallets that are moved around or the truck arrivals are probably subject to change, and we need to understand when the data becomes available, because of course we need all of them available when the reasoning starts, so when the plan starts doing this work, or we need approximations if the data is not available and or the data is not reliable enough. And finally, how often the decision is to be taken. So for example, in a logistics setting, probably you want to decide what to do for the next 8 hours for one human shift. If you want instead to use planning for robotics, then probably you want to react very quickly, for example, in a couple of seconds, to a certain event, right? So I'm observing something with my camera, and I want to react quite quickly to understand what to do. So I will only show you one use case at this point. So for example, optimizing agricultural practices that I was mentioning at the beginning. Here we have this company based in Germany that is essentially a consortium of different other companies working in constructing machines like the harvester that you can see here, and the tractors and so on. And here really what we want to solve is an optimization problem. So we have the capabilities of the different machines, we have the availability of the machines, and what we want to optimize is the fuel consumption, so that not to have, for example, the two tractors arrive too early, otherwise you are wasting fuel. Avoid the waiting times of the machines, because of course also this one is a cost and delays the overall span of the agricultural activity. And an interesting one that I was not aware of is this soil compaction problem. So if you drive many times over and over following the same route, essentially you are compacting the soil, and this actually makes it hard then for the plants to regrow on the compressed soil. And this is actually a form of pollution that we need to avoid, right? So we want to differentiate as much as possible the routes that the machines are taking in order to avoid this problem of compaction. This is a very interesting objective function that I was not aware of. And we have many others in the project. So we have flexible manufacturing, we have robotics, and so on. I wanted to arrive to this point here because probably in this audience you are more interested into what you can do with this piece of code. And so what we are doing, we are developing a library, is a Python library to create this unified planning framework. This is not limited to just plan generation, but it will work with different kind of planning engines. So for example, validation or plan repair, those are all problems that are relevant in our domain. It's written in Python with a strong focus on usability and expressiveness. So our point here is to make planning easy to use as much as possible. The idea will be to have sort of a PyTorch of planning, right? That will be the motto. We released it under a permissively open source license, is Apache 2.0. And since we have just started, it is a 3-year project, it's still under development. But you can follow the development here. We are on GitHub. And here, if you want to later have a look at the slides, there is a live demo on Google Colab. So it's a Python notebook that you can try. That shows the basic features that we currently have implemented, that you can actually see a planner being invoked via our platform. And then Well, I already said this one. So the fact that we are integrating in the AI4EU platform as a service, so by extending the experiment subsystem, providing our UPF, this is mostly intended for small-scale demos and experimentation. Also, Martin was pointing at this one, as for example, Jupyter notebooks and so on. In addition, we are going to provide different pieces of software, possibly as open source, via the platform itself. So the UPF will be a downloadable resource, an asset. Also, the TSBs will be available as downloadable resources, so that a user can actually execute it at his or her own premises in order to do some experimentation. And then also the training is a very important part of our project. And so we plan to create this, we call it planning cookbook, that will be made available through the platform. It's going to be an as simple as possible guide to planning. And then finally, I would like to close the talk by inviting you, or by letting you know that we have these funding opportunities by means of cascade funding. So we call it open calls. In particular, we are looking for use cases. So if you think or if you are aware of someone that it could be interested in having a use case analyzed by our consortium and see whether it actually fits for planning or not, we have this very simple use case. It's super simple to apply. We simply need a description of the problem, and you will be invited to present it to the consortium in a hopefully physical workshop. We'll see how it goes with COVID. And this open call is open now. So if you want, it's open till February. So if you also can help me spread the words, this is very important. All the details, of course, are available on our website. Then we also have a second kind of open call that will be open next year. And here we are really funding sub-projects. So for example, companies that want to use our platform, so our unified planning framework, to solve a certain planning problem can get funded for a 7-month project on which to experiment with our platform, draw some metrics, some evaluation, and report it to us. So that's what we call for innovators. And we also have funding for additional planners, so engines that can be contributed. And there is also the possibility of having consortium of companies developing prototypes and use case providers. So all of this one, I think, is a very nice feature of the project that can help us to reach out to other companies, to other people that might be interesting in order to create this kind of momentum around this technology. So that's what I had for you today, and I will be happy to take any question. Thank you so much.
Thank you, Andrea. Well, so I just wanted also to mention that we have in the room Paul Lukovic from the FKI, who also works with both you, Martin, and Andrea. And from my perspective, that's really one of the things that we need to manage to do with this AICE initiative, is to successfully establish the relationship and the collaboration with this vibrant European AI research ecosystem. I mean, as you said, not everything you do is open source, and not everything we want to do is research. But I think that we can find a good common ground to collaborate on AI research results that are open source, and to give them maybe hopefully more visibility.